review packet here. I presume we want to just kind of start at 1 and go through them.
Yep.
All. Is this the only packet we're going to cover over the next 3 or 4 days, or is there additional?
That's what she passed out. What she said is if it's on here, it could be on the exam.
Okay. So there's not going to be any additional material.
So I definitely double check that, whether it's within the 4 walls of this document.
Okay.
So that's helpful.
Okay. So we'll just start at 1 and go, let's see, we're doing 2 hours tonight?
Yeah, we'll just see how it goes for tonight. I got your book for 2 hours. Yeah, I thought that maybe we could get through, I think it was like through equations and up to X line was about 17. I don't know if it'll go that fast. We'll just see how it goes. I mean, I really want to take this in a relaxed pace. I don't have any, burning schedule, okay. So we'll be fine.
Sounds good. All right. Let's look at 1. What I'd like you to do, Patrick, is just tell me the next line when we're solving these equations. You don't even need to tell me what you're doing. In other words, you don't need to say I'm adding 11 to both sides. Just tell me what the next line should be.
All right, with this one it'd be 5x minus 11 plus 11. Or, oh, sorry.
That's all right. That's all right. I don't usually write. In other words,
yeah.
To me it's kind of a waste of space to write the plus 11 on the left side of the equation. What I know is that the 11 is going to disappear. Okay? What's on the right side?
So that would be, would that be negative 17?
No, remember we're adding 11.
Oh, sorry.
Run them down, Patrick, before you answer. Well, then you get it right. What you're going to do is you put, just so we can get right, what you're going to write down is you're going to put over here.
All right. Let me back up and let me do it the more formal way.
Because that's how you've got to do it to get through. Okay.
We need to add 11 to the left side and add 11 to the right side.
Okay. See how that comes out now.
Okay. And then
yep.
5x, what is minus 6 plus 11?
Would be 5.
Okay. And then finally,
x equals what?
X would equal 1.
All right. Next one, 4/5 x equals minus 16.
So that's 4/5 times. So what we're going to do is divide. Right side, right?
Yeah, so hold on, just give me a second.
Okay. What's your first step going to be?
You're going to divide it.
By?
4/5.
Okay, that's one way to look at it, and the problem is that that produces a fairly difficult method to do it. In other words, if that's what we're doing, that's going to get rid of the 4/5 on the left, but then do you know how to handle the right? It's harder, right? Whenever you're dividing by a fraction. So let me suggest a different way to do this. We've got 2 ways. We can do it in 2 steps, and that's probably the correct way to do it. What would the first step be? Usually you want to get rid of denominators. So how can I get rid of the denominator?
Crap.
Right now the denominator is 5. It's dividing into x. So what do we have to do to get rid of it?
You times by 5.
Multiply it, right. So I can think of doing a first step like this. What's the next line?
Would be 4x equals negative 77.
It's minus 80. Okay. when you get an answer like minus 77, one really good way to check whether that's correct or not is just see if the last digit is a 7. Well, when you multiply 16 times 5, the last digit is that first digit you write. So there's no way that it could end in 7. It's got to end in a 0. Just one little way to check your math. Okay. Now what's the next step?
Then you just divide the 4.
Is it equal to?
What's that equal to?
Oh, hold on.
Okay. What's 8 divided by 4?
2, so got him. So it'd be 20, negative 20.
Okay, good. Now, notice what we did by doing it in 2 steps. The first step, we multiplied by the denominator to get rid of it, and then we used a second step to get rid of the 4. Well, we could do both of those steps in one step if you like, but instead of dividing both sides by 4/5, how about we make it conceptually a little more understandable by multiplying both sides by the reciprocal of that. In other words, if I multiply this fraction by its reciprocal, both of them go away. And that's exactly what we did. We multiplied both sides by 5, and then we divided both sides by 4. So it's okay to do this in one step, but I think it'd be easier for you if you thought of it as multiplying by the reciprocal rather than dividing by the fraction. Merely because when you divide by a fraction, you have to turn it into multiplication anyway. In other words, how would I do this? Minus 16 divided by 4/5, which is a perfectly legitimate way to do it. This is liable to give you problems. Do you know how to solve that?
I don't.
Well, when you divide by a fraction, you flip it and multiply. So in order to solve this, I would just take minus 16 and multiply it by 5/4, which is what I did in the first place. So multiplying by 5/4 actually saves you a step over dividing by 4/5. If you divide by 4/5, you have to then convert it to a multiplication problem. So truly the most efficient way to solve these problems is to multiply by the reciprocal. Okay? Now, when you do this multiplication, tell me how you're going to do it.
You would the multiplication of the negative 16 times the 5/4. Wouldn't you turn the negative 16 into a fraction?
No, I don't need to. I mean, the standard way of multiplying this is to multiply the numerators and then divide by 4. And that gives you minus 80 divided by 4. But there's a better way to do it. And that's to try to reduce these numbers before you multiply. In other words, notice that 4 goes into 16. So I can divide top and bottom by 4, leaving a 1 there and a 4 there. And now when I multiply, I don't have to deal with numbers as big as 80. I get 4 times 5 is 20, and the negative sign is still there, so I get minus 20 direct. Okay?
All right.
All right, this one, 5x minus 2. Now, there's always multiple ways you can proceed with solving an equation. I have my preferences just like everybody else. They may do it slightly different. But the end goal is you kind of want to be able to solve it with as few steps as possible. That's the quickest way. So what's the first thing I need to do here?
You need to distribute the negative term.
Yeah. In other words, you want to get rid of parentheses. It's kind of like if you're solving an equation and there's a list of priorities, the first thing you want to do is get rid of denominators, then you want to get rid of parentheses, and you want to get rid of exponents. You whittle it down so you end up with x. Okay, so if we distribute this 2, what's the rest of it?
It'd be negative 2 minus 2x.
Okay, remember we're distributing a negative 2 to that negative 2x.
So it'd be negative 4.
Positive 4x. In other words, by removing the parentheses, I have to do this process here, including the negative sign. In other words, I have to distribute the negative 2 to the 1, which gives me negative 2. And then I have to distribute the negative 2 to the negative 2x, which gives me plus 4x. Okay.
So now what do you get rid of?
What now?
You can add 2.
Okay. Makes that 16, gets rid of the 2.
It was still 5x plus 4 down.
What next?
Could you take out the 4x?
Oh, is that?
Oh, just add the 4x.
Yeah, there's an expression when you're working with algebra equations that gather all like terms. And that means that combine like terms and like numbers. In other words, if you got a bunch of numbers, add them all together, and you got a bunch of variables, add the ones you can add. Well, I can add 5x and 4x. That's 9x. I'm sure you know that last step. Let's see, let me move this paper up as we go.
You're allowed to use your calculator on this, so when you get to this point, you'll be able to, you'll be able to take 16 and divide it by 9 to come up with x. Okay, so do it.
Well, they may want the fraction 16/9 as the answer. There's nothing wrong with that as an answer. You don't have to convert everything to decimal unless there's instructions that I didn't read that say you round everything off to like 2 decimals or something. Are there?
No, not at all. Okay. So would both of those answers be correct then? But you can just leave it when you get to the
16/9. Yeah, if you could simplify it, you should. In other words, you wouldn't want to leave 16/8 as an answer because I can simplify that to 2. But 16/9 doesn't really simplify. There's nothing I can divide top and bottom by.
Right.
I could convert it to a mixed number, but I personally think that's the better answer, the improper fraction, as opposed to the proper fraction. So I'm quite sure that this would be an acceptable answer. Unless you know different. In other words, you know your teacher. You've had him all year, so maybe he has a preference for mixed fractions instead of improper fractions. I don't know.
Okay, so this is number 4.
What are you going to do here, Patrick?
You're going to add 5.
Okay. So I'll write it like this. Okay, what's the next line?
It'd be 2x equals negative 2x plus 13.
Okay. And next?
And then you can add 2x each side.
Okay.
So it'd be 4x equals 13.
And then again, what's x equal?
That would be 13 over 4.
And again, that's an acceptable answer.
That's the fraction. That's the whole number.
Okay, let's see. What does number 5 say? 5 plus cx?
Yes.
Yeah. And, you know, that was one that when he went through it originally, we had no idea as to what that could possibly mean.
Okay, I know what they mean. I just realized.
Other than to try to get rid of this, I don't know if you could factor the c out.
We'll see if
x equals 7 over c.
that's going to be your answer.
Yeah. So, but what does that c mean, David? Is that just putting in an additional?
It means whatever, yeah, whatever number. It's just an additional variable, exactly. C can be anything. In other words, if c is 2, then x is going to be 7 over 2. But so we end up with x is 7 divided by c, merely because the purpose of solving, or when you solve an algebra equation, you want to isolate x. So whatever you have to do to get rid of everything else, you do. And you'll see the similar thing in problem 9 here. There's 4 variables there. So that doesn't really present any problem. You follow the same exact rules that you follow for solving all of these equations. Treat it like it's a number. In other words, if that was the number 9, then it would be x equals 7 over 9. If it was the number 2, it'd be x equals 7 over 2.
Cool. Yeah, so but you always want to isolate for x, so however it comes out.
Yes, that's always the goal, is isolate for the variable you're trying to solve for.
Do I just solve for x and then put a c under the answer?
Well, what you do is that if you put it one back, first of all, you want to take out your 5, okay? Then you'd have cx equals 7. And then you got to get this x on the one side, so you got to put, you had c times x, so you want to put it over on the other side and divide it, see? So it'd be x equals 7 over c. You have to just make believe like it's a number.
Yes, correct.
But
And that way,
doesn't
well, what you've done is you've still solved for x, and depending on what c, it doesn't matter what c is. Any number that somebody might assign for c, you have the answer. The answer is 12 over c. So it's okay to have your answer have a variable in it. We'll see that when we do number 9. When we solve number 9 for w, we're going to have an answer that has 3 variables in it on the other side of the equation. So you don't always have to have numbers when they give you equations like this. All right, what's the first thing we do on 6?
You know, David, while he's looking at that, on those first 5, he's allowed to take in a sheet front and back of notes. But those first 5 that we did, there's really nothing unique about those problems. You're basically trying to isolate on one side or the other for whatever a single letter is. But now starting with 6, obviously this is where he gets into the inequities, where he wants to have on his note where he wants to cite that rule that if he's dividing by a -2, then he flips that signal.
Okay.
Well, were there any other ones that, any rules at the beginning that you saw?
I don't think so. The first 5 were very basic. I can't think of any rules. I mean, if I was going to have rules, maybe he wants, I don't know, it's up to Patrick or you whether you want to do the following. But if you want to make a list of things, the priorities for solving equations, get rid of denominators. 2, get rid of parentheses. 3, get rid of exponents, things like that.
You know, is that PEMDAS? Where you put it
no, that's a little different. That's a little different. PEMDAS is the order of operation.
You get rid of denominators.
Yeah, I mean,
get rid of
you can do a lot of these things in different orders, so you don't always have to do them in this order. But this is kind of the order that I use. Whoops.
Yeah, what's a good order then? So just so that we've got one. So to be denominators, parentheses, what's that, exponents?
Yeah, denominators, parentheses, and exponents.
So those 3?
Well, there's others, because as equations get parentheses, as equations get more and more complex, there might be other stuff. But in the first 5 equations that we did, that's all we had. We had a denominator and 2, we had parentheses and 3. There weren't any even exponents. So we didn't reach that level of complexity yet. But this is an awfully good place to start. And then, of course, gather like terms. And what I usually mean by that is get all your variables on one side, get all your numbers on another. And then finally, isolate for x, which of course is what you're trying to do the whole time, is you're trying to isolate x.
Okay. Yeah, we'll make up some sort of little map.
Yeah, if you get a little cheat sheet, that's not a bad thing to have on it. Although, I don't know. I'm sure there's lots of stuff you want to put on there, so you're going to have to prioritize what works for you, I guess. All right, let's go back and look at 6 again. Hold on.
Okay, so now on this one here, this is treated as an equal sign for purposes of solving it. You understand that? Okay.
You solve inequalities almost exactly the same way you solve equations. There's only one situation you have to be wary of, and that's when you divide or multiply by a negative number. And when you do that, you have to switch the sign. So what's the first thing you would do here normally?
You add 2.
No, hold on. Let's back up. What is the 2 doing to the x?
Times here. So you want to divide.
Okay, you always want to do the inverse. If it's being added, you want to subtract. If it's being subtracted, you want to add. If it's being multiplied, you want to divide. If it's being divided, you want to multiply. Okay? So I'm going to divide by -2.
Yep.
Okay, there's that situation where we're dividing by a negative number. So that leaves x there, and I have to reverse the sign of the inequality, still divide by -2, so what goes on the right?
-13.
Okay, and there's your answer. X has to be greater than or equal to -13. As long as it is, this will be true. All right. And remember, it's only when you divide or multiply by a negative number. It's not when you add and subtract. You can add and subtract positive and negative numbers all you want. You don't have to turn that sign around. What's the first thing you would do here?
You could add 9.
Okay. Gives us 2x plus 17 is greater than 5x. What now?
You get minus 2x.
Okay. We're gathering our variables on the same side. What's over here?
3x.
Okay. Now what?
You divide.
So you get...
17.
Now, it's worth noting, that's okay as an answer, that 17/3 is greater than x. But your teacher might have a preference to make sure the x is always on the other side. I don't know if that's true or not. That would be an acceptable answer, but it's important for you to know how to move it to the other side. This means the same thing as x is less than 17/3. So if you want to switch the positioning of your final answer, that's what you have to do. If you move x to the left, you have to switch the sign. So I suppose that maybe that would be considered another rule in addition to whenever you multiply or divide by a negative number. You switch the sign. But, okay. This has a very specific meaning. What are the meaning of these bars?
Yeah, it's absolute value.
Okay. So when you have an absolute value equation, it always means two different things. What's the first thing it means?
It means that in the answer you're going to have a plus and a minus.
Well, let's write it out as an equation. In other words, this means that 3x plus 5 equals 14, or what?
3x minus 5.
No, never change what's inside the absolute values. Only change the other stuff.
Okay, so if that was a positive.
And you can write that as a rule because it's going to apply to inequalities with absolute values also. When you write, and the reason I write these horizontally with the or in the middle like that is because we're used to solving equations vertically. So now I'm in position to solve each of these equations vertically, and I'm going to end up with one x over here or another x over there. So let's solve the first equation.
Alright, so you're going to minus 5 from each side.
Okay. Read the next line to me, Patrick.
Alright, so you're going to get 3x equals 11.
What's 14 minus 5?
Sorry, you're going to get 3x equals 9.
Okay.
Sorry about that.
Next line.
No, that's why I did that. You're going to get x equals 3.
Yeah. You don't need to apologize for your arithmetic errors at all. I'll just always point them out, though. And solve this side over here.
So you're going to get 3x, once again 3x minus 5, so you get 3x equals negative 14. And we need about 9.
Okay, hold on. Let me write. Let's do this properly here. Minus 5 from both sides. Now, this operation, again, is giving you a little difficulty. Let's make sure that we don't get tripped up by here. You don't need to be making these arithmetic errors here. What is minus 14 minus 5?
Yeah, negative 19.
Right. We change. This is the subtraction sign. So we change it to an addition, and we change the sign of whatever was being subtracted. We were subtracting a positive 5. So now we're going to add a negative 5. And now you're not going to miss that. That's always minus 19. Okay? So we got 3x equals minus 19. What's x equal?
X equal 6 1/3.
Okay. That's an well, not quite. Plus or minus?
Plus.
It's minus.
Oh, wait, minus.
It's minus. In other words, we're dividing minus 19 by a positive 3. Now, is there a reason you converted that to 6 1/3? Is that what your teacher wants or not?
No. She doesn't really want anything. She's not doing
Then leave it like this. It saves you a step.
All right.
You don't have to do that extra step. That's a perfectly fine answer. The only thing you have to make sure of is that it can't be reduced. Okay? If you have something like 51 over 3, that can be reduced. I can divide top and bottom, or even 51 over 6, say. Well, I can divide 3 into both top and bottom, so that would be 17 over 2. So always check when you get that fraction, that final fraction, and so far we haven't seen any that could be simplified, but that's not to say you won't see it on the test. I would expect you would. We actually did see one. We had 26 divided by 2. So we had to simplify that down to 13. But this one, I can't divide top and bottom by any number. So that's simplified.
So on these absolute values, if the answer is not plus 3 or minus 3, they're actually two different numbers. There's two different actual answers.
That's correct. That's correct. It's either, and let's just try. Let's plug these in and see if they work. Okay? So if I plug in 3 for x, I get 3 times 3 plus 5. Is that 14? And yes, it is. Okay? And if you plug in the other x value, minus 19/3, see, it's much better if it's left as this kind of a fraction, because then when I go to test it, it's easier to test. These 3's cancel. I got minus 19 plus 5. That's a minus 14, the absolute value of which is 14. So these both, and only those, work for x. But neither is more correct than the other. Both numbers are the two answers. Now, I will say that, have you dealt with extraneous solutions yet? Maybe not. No, probably not.
No.
Probably not. Well, I won't say what I was going to say then. All right, let's look at 9.
See, this is the one where it's all letters, but you want to treat them all like numbers.
They want you to solve this for W.
So you're going to get W.
What do I need to do to isolate W?
You need to minus L and minus H.
What's L doing to W right now?
Timesing it, so divide.
Okay, so I need to divide by what?
L.
Well, that's one thing I need to divide by. That'll leave WH. Why don't I just divide by LH all at once? In other words, divide by both things that it's multiplying by. Notice that these now go away, and you got your answer. One step.
You see that? Just like they were numbers.
All right, let's determine whether this is true or not. Well, in order to determine whether it's true, we need to solve it. And as long as we don't end up with 2 equals 3 or something bizarre like that, that would tell us that it's not true. If we ended up with one number equals a different number, that says that it's not a true equation. But if we end up with 3 equals 3 or something like that, then it is true for all x. But what's the first step for solving?
You have to distribute your 3.
Okay, so what's the next line?
It would be 9x minus 9 plus 12.
Notice that we distributed the 3 so we could rid ourselves of the parentheses. Now what?
Plus 9.
Okay. Learn to notice that when you have a variable, boy, I'm a little hesitant to say this, but if you have a 9x on that side and you have a 9x on that side, and they're not being multiplied by anything or divided by anything, but they're only having stuff added and subtracted from it, you can just cancel them out. In other words, it's the same as subtracting 9x from both sides, and both 9x's disappear. But you don't even need to take that step if you get to a point where you recognize it. What I would do here is I would just do this. Okay? Now, yeah, because I just subtracted 9x from both sides. Now combine numbers, what do you got?
You get a 3 equals 3.
And so therefore, that tells you that it has to be true for all x. When you get, in other words, it's not dependent on x. 3 is equal to 3 regardless of what x is. If you're unclear on 11, and this can be a little confusing, let's graph them, first of all. But before we graph these 4 points, is this a function?
Yes.
Is this a function?
No.
So you know the vertical line rule, right? In other words, for something to be a function, it has to pass the vertical line test.
Yeah, I know
Okay,
that.
good. So if I plot these points, I got a point there. The next one, 3 comma minus 1. I got a point there. The next one, 4 comma 3. Puts my point there. And the final one, 2 comma minus 1. It's there. Is that a function?
Yes.
Yeah, it passes the vertical line test. In other words, it's okay to have the same y value for 2 different x's, which is what we have here. We have this value for y is minus 1 when x is 2 and also when x is 3. That does not violate the rule. The function rule is violated when you have the same x value and different y's. Okay? In other words, if I change this 3 to a 4, then when x was 4, there would be 2 different y's. There would be a minus 1 and there would be a 3. That would cause 2 dots to be vertically over one another. That violates the function. That would not be a function. Okay. This one, they give us a table of values and they want us to put it into a function. What's the standard format for a function?
Well, isn't it fx equals?
What's a linear function? Y equals what?
mx plus
Okay.
3.
That's the standard you always want to remember, especially for handling problems like this. And you can always switch y and f of x. Here they're calling it f of x, so let's call it f of x. Okay. Now, what's the slope of this function?
Hold on, I'm just writing that down. So the slope would be negative 3 over negative 1.
Okay. I'm not sure there's a need to bring negative numbers into it, but if you look at the rise over run, it goes from 6 to 9 when x goes from 0 to 1. So that's a rise of 3, a run of 1. It gives you a positive 3 slope. So m equals plus 3. Okay? Now, we would have our answer if they had a, oh, they do, excuse me. Sorry. The fact that there's a point here where x is 0 and f of x is 6, what does that mean for our equation?
That means the y-intercept is 3.
What's when a function crosses the y-axis, what is the x value?
It's to 0.
Aha. So we want to look up here at this table. We want to find where x is 0. Since f of x is 6, when x is 0, 6 is b, or b is 6. Right?
Yep.
Because the y-intercept is always where x is 0, and vice versa. The x-intercept is always where y is 0. So we can't tell the x-intercept from this because there is no place in this table where y is 0. But we can certainly tell the y-intercept. So what's our final equation that would answer the question?
Fx equals 3x plus 6.
Good. And this is pronounced f of x. It's not multiplication, it's just an expression. It means it's a function, and it's a function whose variable is x. So this f of x is a little bit more robust than y. Notice that if I say y equals 3x plus 6, if I just say y, I don't know if it's a function of x or it could be a function of r or whatever. But when you say f of x, I immediately know what's on the other side of that equal sign is going to be the variable x. Also, when you use the f of x notation, it allows you to do stuff like, well, what would f of 3 be? If f of x is 3x plus 6, what would f of 3 be?
It would be f of 3 equals 3 times 3 plus 6.
Okay, good. That's 15. Yeah. Whereas if I had everything defined as y, now I can't really ask that. I don't have any way of saying what is y of 3. I mean, I do, but it's not, that's really using the f of x notation, not the y notation. All right. You're baking cookies. This time they want you to use f of t as the function, which means that whatever function we come up with is not going to have x in it, it's going to have t. And t is time. In other words, the temperature that the cookies are going to be is based on t, how many minutes you cook them. So they don't tell us the function, they just say that we have some function, f of t means temperature, and it's going to be a function of time. So now they say, well, what does f of 5 equal 95 mean? What would you guess? What would you think that that meant?
Well, the temperature after 5 minutes equals 95 degrees.
That's it.
Exactly right. And that's, they just want the common sense answer for it, too. So that's an easy one. Right? Yeah, that's a good one.
Okay, here we have an equation, 4x minus 5y equals minus 2. And they want to know, is this point in the solution set? Is this point a solution for that equation? What do we need to do to determine that?
You just plug them in.
Okay, tell me what to write.
It'd be negative 12 minus 10.
Simplify.
Alright, so you'd get negative 2.
Good. Now notice that I can easily just switch that to plus, but I can still use my rules about subtraction. In other words, if I want to change this subtraction sign to an addition sign, I can do it as long as I change the sign on what was being subtracted. So now I have minus 12 plus 10, and you get negative 2. Since you get one number equals another, yes, it is a solution set. And you don't really have to take the final step here. You might think, well, do I need to add 2 to both sides so that I get 0 equals 0? No, you really don't. Once you get a number equals the same number, you know that you have a solution. Okay, let's solve this so that we isolate y. In other words, when they say solve for y, that's what they mean. End up with, at the bottom of this thing, we want y. And let me be more specific. We not only want y, but we want no y's on this side. When you solve for y, it by definition means that the only y is on the one side of the equation. If I end up with a y over here, then I have not solved it for y. Okay? Not that we would on this, but I just wanted to make sure you understood that. So what's the first thing I'm going to do here?
You could minus 5x.
Okay?
Yeah. So get rid of that. Start stacking the y's on that one left side.
So the next line?
It'd be 2y equals 12 minus 5x.
Okay. Next step?
Don't you want to divide the 2y by 2?
Okay. I have to divide both terms. I can do it like this, or I can do it separate. It doesn't really matter. In other words, it might be a little bit better if we do it like this. And I'll explain why here in a moment. So if I do it like that, the key to remember is that if you divide one side of the equation by a number, 2, then you have to divide the entire other side by 2. I wouldn't be able to just divide the 12. Okay? So I could divide the whole thing by 2, but this way is going to allow me to separate the right side into a number and something that has x in it. And that's what you kind of want to do, is you want to end up with something that looks like mx plus b format. Although it's not necessary to really put it in mx plus b format. They didn't say that. So there's nothing wrong. What's this simplified now?
6 minus 2.5.
Okay, you can switch it to a decimal. There's nothing wrong with that, but you don't need to. In other words, you certainly could leave it as 5 halves. 6 minus 5 halves. The key thing I was trying to get at was you can separate that as its own coefficient of x. This minus 5x over 2 means the same thing as 5 halves x. And that isn't always totally clear to students. And I don't really need to turn this into mx plus b format. They didn't ask for it in mx plus b format. So this is a perfectly fine answer. Now, what would not be a perfectly fine answer is if I go back here and I choose to divide the whole thing by 2 like that and leave it like that. In other words, I don't think that she'd probably take off a point if you left that as the answer for y. I think. I'm not positive. She might not. Because in order to convert the 12 over 2 into a 6, I got to separate those two fractions, like I did.
Yeah, the final one is just more complete. Plus it says solve for y, not 2y. So I don't know.
Well, no, that's okay. I mean, when we divide both sides by y is equal to this over here. But some people might not choose to split that into 2 fractions. In other words, I could see somebody leaving their answer like that, y equals 12 minus 5x divided by 2. Personally, I would want to split it into two fractions and then reduce the 12 halves to 6. Let's talk about that process just a second, for a moment. If I have a plus b over c, and I want to split that into two fractions, what's that equal to, Patrick?
It would be a over c plus b over c.
Okay. How about this? How about if I have a over b plus c?
You have a over b and a over
No.
c.
Trick question. In other words, you can only split it into two fractions when you have a single denominator. I can do it up here because I only have a c in the denominator. I cannot do it down there. That is not equal to a over b plus a over c. So that's why I mentioned it, is a word of caution.
So what would that be? Would it be
Wouldn't
a
be reducible. That would be the final answer.
reducible? Okay.
That's right. It's not reducible. If you plug in some numbers just to check yourself here, let's try this. Okay? That's 1/5. But if I tried splitting it up into two fractions, I'd have 1/2 plus 1/3, and that is not 1/5. So if you ever forget, you can always check these rules that you have memorized and make sure they work. You know, whereas if I had 1 plus 2 over 3, that's clearly 3/3 or 1, but it's also, this is 1. So splitting them up works, whereas splitting them up when I had two things in the denominator does not work, nor should it. All right. Number 16. This is one of the absolute musts of what you have to be able to do. You have to be able to come up with the equation of a line from 2 points. That's the most basic thing in algebra almost. What's the first thing I need?
It'd be y2 minus y1 over x2 minus x1.
So what is that?
It'd be negative 11 over 1. Which would come out to negative 11, right?
Well, hold on. You said negative 11 over 1. If it's y2, you have to go in the same direction. You can't reverse directions. This is y2 here. This is y1. This is x2. This is x1. You can go in whatever direction you want, but make sure it's the same for both x and y. So the first one you did was minus 6 minus 5, which means on the bottom we've got to go 3 minus 4. I can't go 4 minus 3. That's switching directions.
Because what is the formula? Is it
y.
y2 minus y1?
Yeah, y2 minus 1 minus x.
This gives you minus 11 over minus 1, and that becomes plus 11.
No, that's fine.
Okay, so once we have slope, now that's huge to have if you have slope. We have half the equation now. What could I write for the equation?
Y equals 11x plus b.
Okay. How do I find b? Because my final answer is going to be y equals 11x plus whatever b is. So I have to solve for b. How do I do that?
You look when x is 0, so wouldn't that be 11
No. In other words, when you have slope, all you need is 1 point to find the equation. Notice that if I have an equation of a line, if you give me 1 point in that line and I know the slope, then I know the whole line. There's no unknowns there. So we've got slope. I need b. Well, whatever our final equation is has to work for each of these points. So the way to solve for b is plug in one of the points. Which one should we use?
The 4 and the 5?
Yeah, just because there's no negative numbers. So what should I write?
5 equals 11 times 5 plus 2, times 4.
Okay, solve that for b.
5 equals 44 plus 2.
Okay, solve that for b.
That would be b equals 39.
Plus or minus?
Minus 30.
Right. In other words, if you have one number that subtracts a number that's bigger than it, it's got to be negative. In other words, there's no way I can take a small number like 5 and subtract a big number like 44 and have it be positive. So this has to be minus 39. That's equal to b. Now what's my equation that they are seeking?
Y equals 11x minus 39?
Yeah. So there's multiple questions you're going to get on this test. One of them is like this. They give you 2 points and they say, give us the equation of the line. This is exactly how you want to do it. The other is going to be where they give you 1 point and slope. In other words, instead of giving you the second point, if they would have given you the slope, well, that gives you halfway through, so you immediately go into this.
So they either give you 2 points or 1 point plus slope, and then you figure out slope. Good.
Yeah, and they'll even give you maybe the equation of another line and tell you that, okay, our line is parallel to that other line, but it goes through this point. So those are other variations. But ultimately, all of these variations, you need the slope and you need a point. Slope is the critical. Always think, if you don't know where to start, can you figure out the slope? And if you can, that's a pretty good place to start. How do I graph x equal 5? Is that right?
Yes.
Kind of a graph is that?
It's a vertical line.
Going through
5.
What's y equal 3?
It's a horizontal line at 3.
Okay.
What number was that?
17.
What's the slope of the horizontal line?
It's undefined.
Nope.
Oh, it's 0.
The slope of the vertical line is undefined. And notice why. Let's look at slopes.
So hold on for a second. Hey, David, just hold on for a second. The slope of the vertical line is undefined?
Yeah, I'm going to explain that right now. What's this slope right here? Approximately. Patrick?
I'm guessing it'd be 1.
Okay, good. What's this slope? Is that bigger than 1 or less than 1?
Bigger, so it'd be
Okay, we'll call that 2. We'll call this 1. Now what's this slope here?
it'd be maybe 1/2.
Okay. Notice what's happening. As we get closer and closer to a horizontal line, we're getting smaller and smaller numbers.
It's close to 0.
So by the time you get to the horizontal line, it's got to be 0. So that's the way to memorize which one is 0 and which one is undefined. Now let's go in the other direction. Let's go towards a vertical line. This thing keeps getting bigger. That's a slope of 5. That's a slope of 10. Well, a vertical line is a slope of what? If you had to call it something other than undefined, it's a slope of infinity. It is infinitely steep.
That's the vertical.
Undefined means the same as infinitely large. Okay?
All right.
These are pretty straightforward questions.
They are very straightforward so far, but there's like, what, 50 of them on here, you say?
Yeah. I think there's 52 or 53.
Okay,
So.
I'm sure they get harder.
And there's 51 of them, which is 2.
Is this a minus? That's an equal sign?
Yes.
You don't need to.
Yes.
Okay, they want the slope and the Y-intercept. What do we need to do in order to tell them what the slope and the Y-intercept is?
Hold on, I'm trying to find out where we are. Oh, there we are. So we need to get that into y equals mx plus b format.
Okay, what's the first step?
You could get rid of the x by minusing x.
Okay, minusing 5x. What's that, the next line?
Let's see, it would be 45 minus 5x equals 9y.
Now what?
You could divide y by 9.
Okay.
And 45 minus 5x by 9.
Okay. What's that leave? What's it leave on the right?
It leaves 5.
On the right.
Oh, sorry, y.
Okay. What's it leave on the left? Split that into two fractions. Most of the time you want to split this into two fractions. I'll just say that. I'm not saying that every time you would have to, but most of the time you want to. As long as you have a single denominator and you got two things in the numerator, split it into two fractions. So what do we got?
You did 5 minus, let me see, minus point.
No, don't switch it to a decimal.
Just leave it as a fraction.
Oh, so then it'd be 5/9.
Now, the reason you want to leave it as a fraction is because they're looking for slope. Well, we're awfully close to having it into y equals mx plus b format. What do I need to do on the left side to turn that thing into y equals mx plus b format?
You have to
Switch the terms, yeah. In fact, you don't even need to do it. Tell me what the slope is and what the y-intercept is.
The slope would be 5/9, and the slope would be...
Don't forget the negative sign. Don't drop negative signs, ever. In other words, if there's a negative sign and we're going to switch these terms, then I've got to keep that negative sign. This has a positive sign, so that's the way I switch them around. And now the slope is not 5/9, but minus 5/9. And the y-intercept is... Okay. So we don't need y to be on the left. We just need to get one side mx plus b and the other side y. And then you know slope. In other words, it would have been a few extra steps if I had to bring the y over to the left side, so that isn't necessary. But you definitely want to split these two fractions because we need that fraction is the slope and this fraction is the y-intercept.
Okay. What was that? Was that 19?
Yeah. No, that was
18.
All right. Now, this is a kind of a unique problem. First of all, it's in standard format. It's not in slope-intercept format. It's not in point-slope format. I'm not sure you've had point-slope. Have you had point-slope?
Yes.
Okay. Maybe they'll give us a problem that is, we'll have to use it. But There's three formats for linear equations, straight lines. One is standard format, which is this. Standard format, you have the x first, you have the y next, and you have the number on the other side. When a linear equation is in standard format, there is a very easy way to get the x and y intercepts. What did I say x was when we have a y-intercept?
0.
Okay, so plug in 0 for x and solve this equation. It's real easy to plug in 0 because that whole term just disappears.
Wouldn't that just be -3?
Yeah. So the y-intercept is equal to -3. Now do the reverse for the x-intercept. The x-intercept is when y is 0.
So that'd be 2.
Yeah. So when you got standard format and they're looking for intercepts, don't solve it for y. In other words, notice how lost we could get here if we took the wrong step. Let's say, excuse me one moment.
Bless you.
Excuse me. Okay. Let's say I decide, well, I'll solve for y, and then at least I'll know the y-intercept. Okay? So if I solve this for y, I take the 3x on the other side. I got -2y equal -3x plus 6. Divide both sides by -2. That definitely produces the y-intercept. But it doesn't help much with the x-intercept. Now, for me to solve for the x-intercept, I would have to set this equal to y and solve this relatively complicated equation now. So, don't always assume that when you see an equation, you need to turn it into y equals. In other words, don't rely just on slope-intercept format. If there's an easier way to do it, and this is significantly easier.
So, David, but what are the three formats in a point slope format, standard format?
Yeah, that's definitely what you want on your cheat sheet. Let's go through them. The slope-intercept, which is exactly what it says. You have a slope and you have an intercept. Okay, so that's slope-intercept. The next one, the only one we've seen so far is standard format, and that is ax plus by equals c. Notice this was in standard format. A was 3, b was -2, c was 6. And finally, you have point slope.
Point slope.
Which is exactly what it says. You have a slope and a point. And the format of that is y minus y1, where the y1 is the y-coordinate of your point. And that's equal to m times x minus x1, where x1 is the x-coordinate of your point. And we had a problem earlier where we needed the equation of the line, and we got it to a point where we had a slope and a point. Remember?
Yeah.
And the way you solved it was by using this one and solving for b. And there's nothing wrong with that. That's a perfectly acceptable way to do it. But notice the point slope is a little quicker. If I have a slope of, say, 3 and a point of 2, 6, and I want to know the equation of that line, I can plug it directly into the point slope format. In other words, the y sub 1 is 6, the slope is 2, and the x sub 1 is 2. There's my equation all done, one step. When we did it this way, we had to solve that equation, come up with b. So if you are as familiar with point slope as you are slope intercept, then feel free to use it where it's appropriate. Most of my students, they don't like using point slope. I suspect they're not sure they're going to remember it perfectly. And they do remember y equal mx plus b. Most everybody does. So it's perfectly acceptable to use only this as your format when you're solving for those equations. I was just pointing out that point slope does have its usefulness. It gets to an answer quicker. Now you might say, well, that's not really an answer because I have to still add 6 to both sides, which is true, but this actually is an answer. It's perfectly acceptable if they say, give us the equation of the line. If they say, give us the equation of the line in slope-intercept format, then this is not acceptable. You would have to solve this for y and get rid of the parentheses. So a lot depends on what format they ask for it. If they don't ask for it in a particular format, then you're allowed to give any format you want. I could give it in standard format or point slope or slope intercept. Now notice on the next question, they want the equation of the line and they give us a slope and a point, but they want it in slope-intercept format. Okay, so slope is that 2 or minus 2? 2?
Yeah, it's 2.
Okay, and the point is minus 3 comma 1. So, since they want the answer in slope-intercept format, there's no advantage in using point slope. In other words, I could get point slope immediately in one step, but then I have to solve it to get it into slope-intercept. So that being the case, why not let's just start with slope-intercept and not worry about point slope here. So what do I do?
You plug in one of the points. Or
Okay,
plug in the
so
point.
what's the next thing I should write?
1 equals negative, 1 equals 2 times negative 3 plus b.
Okay, what's b equal to?
B would be equal to 4. B would be equal to 7.
Okay. Let me ask you something, Patrick. When you're taking a test like this, would you use a calculator there?
Yes, you're allowed to use a calculator.
Well, it's one thing being allowed to use it, and it's another thing actually using it. In other words, the reason that I maintain that it's so important to have good arithmetic skills is because you don't want to have to use a calculator here. That's a lot of typing to solve something as simple as 1 plus 6. But first of all, you got to multiply 2 times minus 3 and then add 6 to 1. When you're talking low digits like this, it takes, you waste a lot of time if you have to use a calculator to do that.
Right.
So
I guess it's available if he needs it on more complicated problems.
yes, that's, if you have 2 digits, if you've got even 11 times 12, use a calculator by all means. But for solving simple algebraic equations, you want to be really good at, I don't know, I can't really say because I've never tried using a calculator to solve these. It seems to me that it would be awfully cumbersome to have to use a calculator to solve this.
Seems like you'd almost run out of time. I've been trying to impress upon how important that A+ math.
Okay, that was my next thing I was going to say. If you really want to prepare maximally for this thing, spend some time with that A+ math, doing the arithmetic part. Not so much solving equations. I think you're decent on solving equations, but I still see you make a lot of small mistakes on the arithmetic. And if you're doing them on a calculator, it'll slow you down, and if you're doing them in your head, you'll miss some if you keep making those mistakes. So somewhere there's a fine line in between where you can maintain accuracy and speed.
And he should continue to do that A+ math for the arithmetic portion of it right up to the night of the exam, because that's, I mean, I see that all the time. That's where he hangs up, and that's where he gets.
Absolutely.
There's so many problems. I'm like, oh,
Absolutely.
geez, right the
And in fact, if ever we end up with an extra 10 minutes and no problems to work on, I'll always pull up A+ Math and just drill them. And that's exactly what I consider it is. It's like a drill. It's like if you're trying to become a good tennis player, you go out and you hit balls against a tennis machine. You just drill until you get better. And practice does make better. There's no question about it, that if you spend time drilling, you'll get better.
If he had done it every night from when you originally had advised him to do it, he'd have this thing tapped.
Yes.
As far as simple arithmetic functions.
It made a big difference. The first week we started working together and he got better. He got a lot better, but it looks like he's kind of forgot and not back. So I would just say spend some time refreshing on that thing.
Okay. All right, Patty, so which one? Let me see.
So now we can write this thing in slope-intercept format. In other words, I know that it's y equals 2x plus 7.
You have that down there? Where?
All right, that was 20? Yeah. Yeah, now most of these next few, they ask for a specific format. So, and so far it's all slope-intercept. So it doesn't look like they're going to get much into point slope unless it comes later. So what's the equation of the line that passes through these points?
Let's do that. Let's shoot for 25. All right. Because if you look, hold on just for a second, guys. Okay. See, if you break off at 25, that's where you're basically done with writing the equations, and then you'll be getting into the graphs, and then you can pick up the rest of that. So you're at, what, 21? Yeah, so do 21, 22, 22, 23, 24.
Okay, so we should go to 25 and call it a session?
No, sorry. What I'm saying is that we should go up to 25, because then it looks to me like that'll finish with his equation. So I think we're on 21.
Okay. So
which is, I think, is the one you
try to get to 25 tonight? That should be relatively. Yeah, these are relatively quick. So, what do I need to do first here, Patrick?
You need to figure out the slope.
Okay, which is what?
Y
yeah, you don't need to give me that each time. Just tell me what the ratio is.
Oh. All right, let me figure out.
Okay.
So it would be 3 over 2.
What's 9 minus 5?
It would be 4 over 4 over negative.
Okay. Which is what?
That's negative 1/2.
Negative 2.
Oh.
Okay. Same thing, if you're taking a bigger number, dividing it by a smaller number, it has to be a number greater than 1, not less than 1. You can't end up with a fraction if you have the bigger number in the numerator. Okay, now what's the next step now that we have slope?
You plug in one of those points.
Okay, pick one and tell me what the equation to write.
It would be 5 equals negative 2 times 4 plus b.
Okay. B equal to?
Hold on, let me just write that out.
Okay.
So b would equal 8. Sorry.
Don't forget your negatives. Sorry.
Before we try to do this in one step, let's do it in 2 steps. What's the first thing I need to do here?
Negative 2 times 4.
Okay. Now how do I get that negative 8 gone?
You add 8. So,
Okay. So b is equal to what?
b is equal to 13.
Okay. So the equation is what?
Y equals negative 2x plus 13.
Okay. Okay, now they're making it slightly harder. They give us a point, 4 comma minus 2, and they tell us that we're dealing with a line that is parallel to this line. This line over here. This is not the equation of our line, but our line is parallel to this line. What does that tell us?
I always got these wrong, so.
Means the slopes are the same. Here's how you can remember. Those are two parallel lines. What do you notice about them? The slopes are the same. Okay? There's two situations. One is parallel, where the slopes are the same, and the other is perpendicular. If I draw a perpendicular to that, clearly the slope is opposite sign, right? So you can always keep them straight by just drawing a line and seeing where the slope is the same and where the slope is completely different. So the slope is 3. Well, now we're back to the same problem we keep doing. We have a slope and we have a point. Tell me what to write.
So you put y equals...
Sorry, I didn't mean to write y equals there. And let's get rid of this because that is no longer necessary. The only thing we needed that for was to get slope. We didn't care anything else about it.
You put negative 2 equals 3 times 4 plus b.
Is b equal to?
B would be negative 14.
Good. You did that one quick. And so the equation is?
Y equals 3x minus 14.
Yeah. $23. Okay. What does it mean to be perpendicular?
Oh, and hold on, David. Is that so the parallel line actually was y equals 3x plus, y equals 3x minus 14. That's the parallel line to that first one?
That's the equation of the line that is parallel with this line and passes through this point.
Okay.
So the answer that they're looking for is y equals 3x minus 14. And notice that that's the same line as that, only a different y-intercept, right? So this line here looks like this, has a y-intercept of minus 4 and a slope of 3. This line here that we came up with goes through 14 way down there, but it has the same slope, so it's parallel to the other line. Now, perpendicular. What does perpendicular mean about slope? 2 words requiring 2 actions. The slope of this line is what? The slope of the line that they gave us the equation for.
Wouldn't that be the opposite?
Well, what's the slope of this line?
Oh, it's 1 over 2.
Negative 1 over 2. So what is the slope of the line perpendicular to that?
Would it be the opposite?
It's opposite sign, but there's 2 words. It's negative reciprocal, which means it's the opposite sign and it has to be flipped.
Oh,
Negative flip, if you will, if that's easier to remember. But always remember that there's 2 things you have to do to get the perpendicular slope. It's not a one-step process, it's 2 things. If you remember 2 things, you'll probably get it. because how many things can you do to that? They're not much. You can change its sign and you can flip it. So what's the slope of the perpendicular?
It'd be y.
Now just what's the slope?
It'd be plus 2 over 1.
Just 2. Yeah, that's the same as plus 2 over 1. Okay, and we're back to our same problem. It passes through this point right here. What's that point? 5 comma minus 4?
Yes.
In other words, every one of these problems we do preliminary stuff and we end up with a slope and a point. Take it from here.
So you plug in.
Just tell me what to write.
It'd be negative 4 equals 2 times 5 plus 12.
Hold on. Plus b. Remember? Remember, this is not the equation of our line. In other words, the only thing I need from this equation is that slope. I don't even want to pay attention to this 12 because it has nothing to do with my answer. My slope is 2 and it goes through this point. So I'm going to have a different b. In other words, they're not going to have the same y-intercept at all. So you have to go through every single step that we've been going through, which is to substitute slope and the point and solve for b. What's b equal to?
Negative 14.
It's the equation.
Y equals 2x minus 14.
Right. See, that has a different y-intercept completely. All right. Bring up the next page. How many pages do I have here?
You should have just one.
Okay. You want to verbalize the next two?
Yeah, because did you not get a copy of 24 and 25? It's on the right-hand side of your page, maybe? No? It's not.
Hold on.
Here it is. It's actually the right-hand column.
I just haven't... oh, I closed it out already. Here, let me open it up again. Sorry about that. I just assumed it was on another page. What happened to 24?
It should be on the right side, but we can read it to you. I saw it actually when you called it up. It was on the
I see it. It's up top. Yeah, I didn't go high.
Yep, the graph.
Okay.
It wants you to write the equation for that line on that graph. See,
Which is pretty simple.
There you go. Then what can I do? We can polish it.
What's the first thing we should look for here?
Slope.
Okay. What's the slope of this line?
You go over 2, up 3. So that'd be the.
So slope is what?
2 over 3.
What's the verbal definition of slope?
Rise over run. So it'd be 3 over 2.
Okay. I actually prefer memorizing it as rise over run as opposed to this long complicated thing here. I mean, I know this is what they teach you and this is what you eventually have to know is that. But if you start with rise over run, that tells you which variable goes in the numerator because the rise is the y-axis. What else do we need to be able to write this equation?
The Y-intercept.
What is that?
Let me just count real quick. It's about 7.
Looks like it's 8 to me.
Count it one more time. Look, I'm trying to.
Yeah.
I know it's hard to see. So.
Make sure you count all the way up to that point right there. That's where it crosses the y-axis, not one below. It is hard to see, but clearly they...
It's 9.
1, 2, 3, 4, 5, 6, 7, 8.
Oh, guess it is 8.
Yeah, see what crosses?
Yeah, it's
Oh, cool.
Okay, so that's just plus 8. Now, it's not really fair of them to give you a line on a grid that is not marked. In other words, it's plus 8, assuming each one of these is 1. But they don't really tell you that. I guess if they don't label it, we can assume that each grid is 1 unit. All right. Write the equation of the line in point-slope form that passes through the given point and has that slope. So, what should I do here?
You put in parentheses, would it be 4 minus y1?
It's always, it's y minus y1. And over on this side, it's x minus x1. Remember, there's only one unknown point. So it has to be subtracted from your main variables. Okay? So what's the equation? And there's nothing else to do. In other words, when we write the equation, that will be the answer, assuming we write it in point-slope format. We could take the long way around. Actually, we couldn't. I mean, we could get it in y equal mx plus b format pretty easily, but then switching that to point slope is not so easy. We don't know how to do that. But since they gave us a point and a slope, let's just put it immediately into point slope. What is it?
So would it be y minus 4 equals 1 over 3, comma, x
Not
minus,
comma, parentheses.
I'm sorry, comma.
That's okay.
I don't know why I said that. So parentheses x minus 6.
Careful.
Like,
In other words, here's the standard. What's x1?
it's unknown.
It's negative 6.
Oh,
Okay, so it's x minus a minus 6. Which turns into what? In other words, you wouldn't want to give this as an answer because it's not simplified.
It'd be x plus 6?
Yeah, that is an answer. And you don't have to get rid of the parentheses. In other words, this is the final answer. That is in point-slope form. If I distributed this, it wouldn't actually be in point-slope form anymore. So if they specifically ask for point-slope form, leave the parentheses. Don't distribute. And that's a little unusual. Normally you would always distribute this, but not in this case. Although I doubt she would take off if you did this. If you did distribute it, and you gave this as an answer, I don't think I don't know. I don't know if your teacher would accept that or not. It depends on the teacher. This is technically point-slope format. I'm not sure that this is. Want to call it a night?
Yeah.
Okay. And we'll pick up. Yeah, math is something that you reach a point in time where your brain kind of fries, and there's not really...
And I think that's about an hour and a half, too, with him. Probably with you the same way, Dave.
Well,
So,
I wish it was. It's a good thing it's not that way with me, because I frequently have to do like 6 hours in a row. This with different students.
You have to do 8 hours in a row.
Yeah.
Yeah, so that's cool. So then we'll see you tomorrow. I can't remember what time that was, but I'll check my phone.
I've got you down for 11 a.m. and then again at 1.
Yeah, it's the only way I could fit it in. So we'll do an hour, then give them a break, and then see what we can do with that next hour. We'll pick up.
That actually works pretty good. If you wanted to do 2 hours in a row, I can do something here. I can switch around. That's my lunch hour there, so I don't care. If you wanted to do 2 hours in a row, but I would actually recommend you do an hour, a break, and another hour. I think
it's better the way that we got it, because then we're on 25, and like I said before, I think we got 53 questions.
I agree. Totally.
Yeah.
Totally.
But we're looking good. And then I thought that actually once we got this one exam done, then maybe we could sit down and have you put together some other exams using these premises.
I can do that. I can absolutely.
Yeah, you know what I mean? Because that's what I told him. Since he's going to stick with these premises, if we just drill these like model exams, I guess that would give us the best probability of doing.
No, I like that plan. I think it'll work.
All right, David. Well, then we'll wait to hear from you then tomorrow. Nice talking to you again, obviously. And,
okay. Talk to you tomorrow, Patrick. Bye-bye.